Greetings, Earthfolk. It's been over a month since we started porting Project Tactics to Unreal Engine, and it's time to show the progress. This devlog is 10 days late. The reason was my fixation on perfecting one of my shaders. More on that later. Things will look and feel significantly different than the Unity version, and it's better in many ways. I'll go over the creative parts, while Raga will present the game mechanics and technical aspects of the game. Let's roll!
First, I watched all the tutorial videos for the advanced turn-based tile toolkit. Then, I created a new Unreal project from the toolkit and played the demo map. Now it was time to get my hands dirty. Project Tactics will have movement points, action points, and strategy points. The toolkit did not have all 3 points, so I added them. In our game, each unit will not lose remaining points at the end of each turn. Instead, a small number of points will be added to the pool each turn. The player can choose to use more points in a particular turn or save them for a future turn. Since 2 new types of points were added, the base ability class also got 2 new parameters for their cost. The code to deduct turn points for performing the selected ability was also updated, and in many places changes were made. With the point system in place, it's time to modify and add abilities. The move action and the basic attack abilities were tweaked accordingly. We have guns like shotgun that aim and damage in a cone. The toolkit didn't have the functionality to damage units in a cone or even calculate grid position in a cone. So I started by making a function to get all grid positions in a cone from a given starting point, field of view, and axis of cone. Using a vector from unit to the cursor as the axis of cone, I coded the attack and cone ability to show all the damageable grid squares. After some minor bugs and fixes, it was the prime. The same cone functionality was added to the Overwatch action. The Overwatch action present in the toolkit was similar to that of Xcom 2, but we wanted Overwatch like in GearsTactics, where Overwatch covers a cone and the player can set its range. As of now, our Overwatch ability covers the cone area till the maximum range. There was no reload action, so I implemented a reload action, and with this all basic abilities were completed. Now it was time to add the myriad abilities the players would unlock in the unit skill tree. For example, burst fire ability for assault rifles. The unit takes 2 shots at the same target with this ability. The next big thing to improve was the status effect system. In the toolkit, effects once applied have to be removed manually, and there was no functionality to apply a status effect for a certain number of turns. Currently, I have created only 6 effects, 3 of them being skip turn, increase the damage of the gun, and increase damage received when hit. Moving on, it was time to modify the cover system and damage calculations for target units in cover. Our game would not have hit chances. Instead, every shot will do damage, but the amount of damage will depend on the distance between the attacking unit and the target unit, in addition to the cover the target unit is in, and the angle of shot to the cover. Full cover will provide a damage reduction of 25 to 50%, and half cover will provide a 12.5 to 25% damage reduction. The final value of cover damage reduction is now in hands of RNG gods. Further, I worked on creating an ability to switch weapons and added the corresponding UI. Abilities corresponding to a weapon like reload, weapon use, and other abilities like burst fire for assault rifles are shown when that particular weapon is selected. Otherwise, they are not displayed on the UI. Not all systems are complete. Like in the UI, many icons and text are placeholders. The most crucial system remaining is the enemy AI.
Before I began, I felt moderately procrastinative, and starting with shaders and animations felt daunting. Instead, I finished the ad hoc task of importing all character models and weapon models and setting up their materials correctly. I also set up a Perforce server on Raspberry Pi 4 as it works seamlessly with Unreal Engine. Frustratingly, the HDD let out squeaks of death the same night, so it had to be set up again on a new HDD. Now I felt ready to dive into the fabulous world of shader creation. Just like before, I started with an outline shader. The final outline shader had depth-based outline, normal-based outlines, depth-based scaling, distance-based culling, and a multicolor option. Outline shader was the easiest and most noticeable prima facie. After this, I created a shader for custom ambient occlusion. Initially, it applied a hatching pattern to all shadows, then I changed it to AO only. I had to change the dynamic global illumination from lumen to a deprecated ray tracing illumination to get an AO map. I generated hatching lines procedurally instead of using a texture. But then I tried a dotted pattern as well. The dots were also procedurally generated and they fit better in the world we were creating. The shader has options for AO strength, dot size, angle, color, and transparency. Do let me know in the comments which one looks better, though I keep what I prefer anyway. The signature comic book look required halftone dotting as well. In Project Tactics, halftone will be applied to high illumination paths and bloom. Simple task? Nope. The only way to get bloom texture in post-processing material is to replace tone mapper, which in turn forces me to recreate the tone mapper. After a lot of hair-pulling shader math, I achieved a look I was satisfied with and added it to my custom tone mapper. Originally, I used bend-day dotting, but eventually changed it to halftone. The halftone shader has bloom spread, dot size, and fall-off range controls. The last piece was cell shading, which itself was quite easy to make. The problem arose in making it work with other shaders. Blending before tone mapping broke halftone dots by removing all lighting data. And I cannot extract lighting data after tone mapping. Solution? Simply copying the cell shaded graph to halftone shader and using cell shaded output as input for the custom tone mapper. Awesome! Nah, I'm still not satisfied. The colors are atrocious. I have a few ideas to fix this, but I spent too much time already. There's also a minuscule probability of using a custom build of the Unreal Engine. My next task is creating either a level or an animation blueprint for the characters and adding animations. Please like, share, and subscribe to follow our journey. And I'll be back, older, wiser, stressed.